Okay, so this next example here is very similar to the one we saw before, to the one we saw before that, and the one we started with. Okay, the first part of it's the same, but the axis of revolution is located in a different spot. Okay, so the first thing I'm going to do is I'm going to redraw the picture so I know what I'm dealing with. Okay, so let's see, y equals 2, 1, 2. Y equals okay, 1, 2, oops, not 2. 1, -1, got a dot there, dot there. This is still the bounded region. Green stuff's still the bounded region. Okay, so that part setup has been the same for all the problems we've done so far. The part that I've changed is the about. The revolutions, where you revolving around. Well, this one's x equals 7. Okay. Well, x equals 7. Oops. 2, 3, 4, 5, 6. Here, let me make this a little more. It's not going to be to scale, but just so I can fit it on here. Change the color. Okay, x equals 7. Okay. This is y equals x squared plus 1, and then the red is y equals 2. Okay. Okay, so this guy, if it's going to revolve around a vertical line, that means it's got to revolve differently than the last ones. So this is the first problem where we're revolving like that. Okay, it's going to revolve around the y-axis, or the not the y-axis, but the x equals 7. So this one, if this is the case, then this is dy. Okay, that's how it's easy to tell. If you're revolving around a vertical line, it's dy. If you're revolving around a horizontal line, it's dx. Okay, so here's the thing about it. Big R and little r are exactly the same. We're still going to do a big R and we're still going to do a little r. And volume is still going to be exactly the same formula. Volume equals pi big R squared minus little r squared, except this one's going to be dy. Okay. Okay, so we always, when we're trying to find big R and little r, we always start with the axis of revolution. Okay, so I'm going to make a dot here. Okay, so if we go to the outer, except before when we did big R and little r, I was always going vertical, up and down, right? Up and down, right? Big R and little r will always up and down. Now it's not going to be up and down because the axis of revolution is to the right or to the left. Okay. So instead of doing that, I'm going to have to go, wait 1 second, where am I at? to the left. Okay? So big R is from here till it hits the outside. Till you hit the outside function. Wait, let me do this. Till you hit the outside function. Okay, let me double check my notes real quick before I tell you. Let's see. Okay. Yep. So when we do that, we usually go top minus bottom, right? We usually go top minus bottom. But because this is in a different direction, we can't go top minus bottom. Okay? So instead, let me say, I believe we go right. Let's see. So we go right minus left. So which one would be right and which one would be left? We go right minus left. All right. So 7 minus. Mhm. Yeah, we couldn't put x squared minus 1 here, right? So solve for x. What do you get? Solve for x. What do you get? Pencil, paper. Solve for x. What do you get? Say it again. Say it loud. Square root y minus 1. Okay. Squared. What about the lost? What about the bottom one? Or not the bottom one. Sorry. R. What I mean by bottom one is R. How do I find big R? Or sorry, it just found big R. What about little r? Mhm. Say it again. Which function? You said something. So 7 minus x squared plus 1. Sorry. So you'd be from here to here. So that would be. Seven plus. Let me double check. Let's see. Because y equals x squared plus 1, right? And then you solve for x, so you get y minus 1 equals x squared. And then you solve for x. So you get x equals, oh, I see what you mean, because of the plus and minus. Would it be? So when would we have a plus and when would we have a minus?
Like if you plug in y equals 2,
Uh-huh.
2 minus 1, you get 1. Square root of 1 is 1, but plus minus 1. So there's negative 1, 2, and 1, 2
Oh, yeah.
coordinates. But since with the big R, you're doing the far left.
Yeah.
It's on the negative side.
It might be. It might be. Yeah. Let's keep going and let's see. Maybe we'll come back to that. Yeah, it's a good. That's a good observation. Yeah. So let's keep going. Let's keep going. I think you're right, but I can't remember writing in my notes. So let's keep going. Okay. So the bottom R, little r. Little r is what? What is little r going to be? Mhm. Okay. Okay. So we put those in. How do we do the rest? How do I solve for the volume? I think so, but I don't know because it's squared, right? I can't distribute the negative, right, and combine them. It looks like it's going to be 0, but how? That was my first question. That's my question. How can I check to make sure it's going to be 0? Mhm.
If you distribute the squared, it's the same.
Yeah. So how do I do that? What's that procedure to distribute? Because it's not like I'm not going to be able to do 7 squared and y minus 1 square root squared because that's not proper math. What's the correct math for doing that? FOIL, yeah, yeah, FOIL. That's the correct method. So let's FOIL them, or multiplication box, however you were taught. It's the same thing. Okay, so first 49 outer -7 root y minus 1 inner. I'm going to get the same thing. Last is positive y plus 1. So I'm going to have 50 minus 14 y minus 1 plus y plus 1. I can combine the 1 and the 50. I get 51 plus 1. Okay. So each one of those is going to be that. Oops, why did I put plus 1? 3 minus 1. Y minus 1. So that's going to be 49. 48. Okay, so each one of those is going to be that. So if I distribute a negative, so you're going to have one here, and you're going to have one here. So if I distribute a negative, you're going to have over here, after I foiled and distribute a negative, you're going to have negative, positive, negative, right? Those will cancel out and make 0. So we do get 0. So obviously this is not going to make a 0, right? Obviously there is something here. And if it revolves, it's going to be not 0. So what do I do instead? Because the volume is not going to be 0. Because there's stuff there, right? And it's going to revolve around, and it's going to create like a donut with a flat edge. One side of the donut's going to be curved like a regular donut, and the other side will have a flat edge. That's what it's going to create when it revolves around x equals 7. It's going to come out like this and go around, come out, go around. So what do we do? We got tests on Friday, Thursday and Friday. So someone say something, or we're going to not be as prepared as we all want to be, right? So don't just stare at the ground. Don't just stare at the desk. What if you have this question on the test or some variation of it, right? Hmm? That's what I was thinking. Yeah, that's the only thing I can see here is what Sebastian was saying. Here's the thing about quadratics is they do not have they don't have inverses. The reason they don't have inverses is because of this, because really this process is finding the inverse. They don't have inverses because of the plus and minus, because it could be a plus, it could be a minus, right? So the negative side would be the minus and the positive side would be the positive. So when we wrote this guy, the top one's going to stay negative, but the bottom one's going to be positive. Okay? So that means this guy right here will be positive. Now that's going to change some things, but not everything. Because when we do FOIL here, you're going to get the same numbers. The signs will be a little different though. Or the same, you're going to get the same outcome. The signs will be different though. So this guy will have this guy. This guy over here will have something very similar. It'll have a 49. It'll have a plus 14 square root of 1. And it'll have a plus y. Okay, so let's write this. So 49 minus 14 square root y minus 1 plus y minus 49 plus 14y minus 1. And then it would still be okay. Oops, not squared no more. So the 14s would cancel out. When I distribute, the y's would also cancel out, but the middle terms would not cancel out. So we'd have negative 28 square root y minus 1 dy. Okay. And then you would go from there. If you needed to do it by hand, how would I do it by hand? I'm not going to finish this problem just because I want to get to the last couple problems. If I needed to do this by hand, how would I do it by calculator? You just plug it in the calculator. That's easy. But how would I do it by hand if I needed to do it by hand? Yeah, I would have to use u substitution. This would be my u. Y minus 1 would be my u. Do u substitution that way. Oh, what are my bounds? What would my bounds be? Would they be the same? Negative 1, positive 1? Mm-hmm. There you go. Since it's revolving this way, your bottom bound would be here, your top bound would be here. So we know the bottom bound is 1 because that's what 1 is here. And then the top bound here, this is y equals 2. So it'd be 1 to 2. Okay. All right. Okay. All right, so let's go to I don't want to do that one. I want to do the next one. Let's see. Let's do the next one, and if we have time, we'll do the last one. Is kind of like is good practice, but if we don't get to it, we won't get to it. Actually, you know what? Find the volume. Which one does this revolve? This one revolves this way. Let's do another horizontal. Let's do this one here. B, letter B. Let's do another horizontal. So if we don't have time to do another one, you'll have 2 horizontals. The graph's already given to you. Okay. So you have a parabola. You have y equals 0. Y equals 0 is right here. X equals 2 is right here. So the red stuff is the bounded part. So it's going to revolve around the y-axis, So it's going to revolve about I shouldn't have done that. Let me see. The solid line. Okay. That line, that blue line there. It's going to revolve around the blue line there. So when it revolves around the blue line, it's going to come around and come around and come around and come around. It's going to create kind of a bowl with a point with a lip here. This is the bottom of the bowl. The bowl has a missing part. The missing part is here. Like a bowl has. When you have a bowl, right? It's got a missing part in the middle where you put your food or cereal or whatever you have in there. Okay. Okay, so since it revolves about the y, we're still going to have to do big R, little r. Okay. So anytime we're finding big R and little r, we start with the axis of revolution. So I'm going to make a dot on the axis of revolution. Anywhere within the bounds of the axis of revolution. And I'm going to draw to the right or to the left until I hit the outside of the shaded part. That's big R. That represents big R. And then little r is going to be the same thing, except now I'm going to stop at the inside of the shaded part. Okay. Okay, so start with big R. Right minus left. Right minus left. Okay, so if you don't have those written down, make sure you do. Right minus left, or watch this video. Okay, so right minus left. Well, the right is over here. That is represented by this line, which is x equals 2. Okay, so 2 minus the left is where I started, the y-axis. Well, the y-axis is just x equals 0. Okay. All right, little r. So little r, the right, is the parabola. The right is the parabola. Okay. Since it's only on the positive side, we're only going to use the positive. So y equals x squared. So this guy right here is y equals 2x squared. Sorry, 2x squared. But again, this is going to be a dy problem. This is a dy problem because it's revolving about the y-axis. So I have to solve for y. Sorry, solve for x. So y equals 2x squared. Divide both sides by 2. I get x squared equals y over 2. I take the square root, and I get the square root of, I get plus or minus, right? You get plus or minus the square root of y divided by 2. Now I only want the positives in this case because I'm only dealing with the positives. This is only happening in the first quadrant, right? Only happening in the first quadrant. It's not extending past the first quadrant. Okay? Question? Good? Questions? We good? Okay. So I don't have to worry about the negatives. There's no chance of me getting a negative number. That's why I don't have to worry about the negatives, right? The last one, part of it was on the left side, right? So there was a chance of getting the negative. X could be negative. Over here, X has no chance of being negative, okay? So that's going to be my right. My right is going to be that guy, the positive one. Minus the left where I started, which is the green dot to green dot, which is 0. Okay. So big R is going to be 2. Little r is just going to be the square root of y divided by 2. Okay, so let's go down here. Let's rewrite that. 2 squared minus square root, oops, should be a square root over the both of them. Dy. Okay, so we still need bounds. Okay, so our bounds are going to be, what are they going to be? Are they going to be top, bottom? Or are they going to be left, right? Where are the bounds going to be? If it's dy, top, bottom, left, right. Top, bottom, just like the last one, right? Top, bottom. Okay. Well, look at the red stuff. Look at the red stuff. Where is the bottom of the red stuff with respect to y? In terms of y, where is the bottom of the red stuff? In terms of y. Only in terms of y. Where is the bottom of the red stuff? 0, yeah. 0, right? Bottom's out at 0. And it looks like the top is at 8, but it might be 8.1, 8. This graph might not be. So to figure out where this point is, because that's the point, that would point represent the top, you would set these two functions equal to each other. You would set this guy and this guy equal to each other. One of them's x equals 2, and one of them's y equals 2x squared. Okay, you would set those equal to each other. But I wouldn't set them equal to each other right now because one is with respect to x and one is with respect to y. So what I would have to do is plug in this guy here. I would plug in this guy here. I would say this guy, where is this guy equal to that? So I would set up like this. And solve for y. Square it. Multiply by 2, you get 8. Multiply by 2, multiply by 2, you get y equals 8. So the other one would be 8. Okay. So didn't say if this is a calculator or non-calculator question on the test. I will tell you if it's a calculator or non-calculator question. You don't have to worry about guessing. Okay, I will say these are calculator questions. These are no calculator questions. Okay. So this guy here would just be y minus 2 dy. Okay. So if it's a calculator question, you just plug it into your calculator. If it's not a calculator question, you just do the antiderivative. Okay, you just do the antiderivative of that and then fundamental theorem. So just like again, for sake of time, because that we've done that before already, so I'm not going to spend too much time on the calculator or antiderivative. You would get about 50.265. 50.265 if you use the calculator. If you didn't use the calculator, you would get 16 pi. 16 pi. Okay. All right. Okay, so let's see. All right, so what I want you to do now is try this problem that we skipped earlier, that we just skipped. I want you to do this one completely 100% on your own. I'll give you 10 minutes or so to do that. And then we'll go over. Okay. So the first thing, before I show you what answer I got, first thing I'm going to do is my graph. Because once you draw the graph, it becomes very apparent dy or dx, top versus bottom, big R versus little r. So the purple is going to be big R. The green is going to be little r. The axis of revolution is a -1. So then you can see, okay, well, this guy right here is going to be top minus bottom for big R. And then this guy right here is going to be top minus bottom for little r. Okay, that's just drawing. You know how I drew that graph? I plugged in points. That's it. Every single one of you guys can do that. So even if you don't know what this graph is, you should know what this graph looks like. And you should know what this graph looks like by memory. This graph right here that I'm circling looks like this. This graph here is the square root, looks like that. Even if you didn't know what it looks like, plug in x plug in y. That's literally all I did. See these dots here? That's what that was, okay? So every one of you should be able to graph that. And when you graph that, you can see where the bounded region is, okay? That's the only area that's completely bounded within. Draw your axis of revolution. Go from there, okay? So once I did that, I found big R was the square root of x minus 1 minus a negative 1. Little r was 1 over x minus a negative 1. So that just became plus plus. Okay. Then from there, the only other thing left to find is the bounds. Well, since it's dx, it's going to be left to right. So there's one bound and there's another bound. Well, where do these two guys cross? They cross at 1. And where does this end? It ends at 4. X equals 4. Okay. Okay, so let's see, do we have time for one? Let's try. We got time for one more. Let's try. Let's go to the last question. Very, very last, part C. Part C. Since this is our last day covering this, I want to make sure we have some practice. So do that one. I'll give you about 5 minutes to do that, and I'll give you the answer. Okay, use your calculator. You can use your calculator for this one. Okay, go. Graph's already drawn for you, so you don't have to memorize. You don't have to draw the graph. All right,